Yes. All right, so number 1 was letter A, so you should have given yourself a check or an X on learning target number 3, right? Okay, now let's go through kind of the process on how I expect you to tackle a question like this, okay? Because, this is a decimal, this is a mixed number. Is it possible to compare fractions and decimals without doing something first? Like, can you just look, if I gave you something crazy like 0.9872 and 398 over 402, could you guys tell me which one of those is larger?
Yeah.
No, you couldn't, because I can't. I would have to do the work. That's my point. So, you got to show some work here. So, I think it's easiest to convert the decimals into mixed numbers. What are you doing? Don't worry. There's more back there. Go get them. Okay, so what I mean by that is I'm going to take 7.2. Okay, here's 7 1/3. And then 7.2, which that isn't the way I like you to say it, even though I'm as bad as anyone at saying it that way. You got to say it the way it's supposed to be read. Okay, so this would be 7. The decimal is an and. So 7 and 2. And then what place value does 2 have?
10.
Tenths? Where's your stuff? Where's your notes? 7 2/10. And there we go. All right, so now that we've converted 7 2/10 into a mixed number, remember, fractions can never be compared. Like, again, if I gave you this fraction and I gave you 98, 101, if I asked you to compare those, are you going to be able to just look at them and tell? No, because they're so close. They're so close that it's too hard to really tell. Okay, so that's what I mean. This is where you got to find a common denominator. A common denominator here, a good one would be 30, right, guys? Okay, remember what you did to the bottom, you must do to the top. And that's times 3, so that'd be 6. And then this would be times 10, so that'd be 10. So what's more pizza, 7 6/30 or 7 10/30? This one's larger. So is A actually the correct answer? Yes, it is. One more thing, by the way. I forgot to mention this. I'm going to try to put the correct answer up there before I go over each one. All right? So if you know you missed it, you better be writing down what I'm writing down, because this formative is now a study guide. I don't even take them back. You keep them from this point on. So wouldn't it make sense for you to put the appropriate work down, to put the correct answers down so that you can have something to go off of? Okay. So even if you did get it right, it might not be a bad idea to just go ahead and just write what I'm writing, just to get it down to make sure you're all good. Here we got 7 1/5. One thing that drives me crazy is when students, this is a bad habit of everybody, adults, kids, everybody, they look for the correct answer, which I know is what you're supposed to do. My rule on multiple choice questions, find me the 3 wrong answers. So basically prove that they're wrong. If you ever want to be certain that you're not making an error, find the 3 wrong ones, and that'll lead you to the correct one. And then you can prove, we already proved that one's right, but let's just prove that these are incorrect. So B would be 7 1/5, and that's going to be 7 3/10. Okay, again, I got to have a common denominator, and it's 7 3/10, just like you see it there. Okay, common denominator would be 10 here. Whatever I did to the bottom, I must do to the top. Which one's larger, guys? 7 3/10. So that would be a less than symbol. Is that showing that? No, so I'd put a line through it. This one over here. 7 3/4. And we have 7 9/10. What would be a good common denominator to use here?
40.
40 would be perfect. I could also use 20. And I see some of you not writing this down, and that concerns me. After I just said that it might be a good idea. Times 4. This would be 36. Which one's larger? Isn't 36/40 more than 30/40? So that should be that symbol, is it? Hello? No. This one, 7.7, would be 7 7/10, and then 7 1/2. What would be a good common denominator to use there? Wouldn't 10 be a good, 20 or 10? I'm just going to use 10. That way I only have to change one of these fractions. That's times 5. That's times 5. So So wouldn't 7 and 7/10 be larger than 7 and 5/10?
Yes.
But is that what that's showing? No. So do you see how I found the 3 wrong answers?
Yeah.
So you just got to understand that the place value is how you write it. So something like this, 2.98, that would be 2 and 98. And then what place value does the 8 have? Hundredths, right? So that would be 98 over 100. Okay? There you go. Sorry. I know some of you were still writing that. All right. Number 2. Okay? The correct answer is going to be letter D. However, listen closely. If you did not have the work, it's wrong. Okay? The only way I've ever showed you how to do prime factorization, I never once have taught you to just look at the answers and find the correct answer. Every time you've done prime factorization, what have you done? The factor tree. So you must have this factor tree. If you don't, it's wrong. Yeah.
Why did a scrap piece of paper?
What's the scrap piece of paper?
I recycled it.
Well, I mean, the work's got to be there. I said that before the test started. Right? I don't know. We'll talk about it here in a little bit. All right. So you must have that. So if you didn't have that work, it is wrong, and it wouldn't be a bad idea to write yourself a note. Whenever you're pretty much every question on this entire test, you had to do trees that's the first step. I would say every question, there's 31 questions, probably 25 of them, you had to do trees. That was the first step regardless. So if you didn't do it on them, it's going to be wrong. Rich? Okay, so obviously I put A on there to kind of throw you a little bit. Remember, prime factorization, like if you look down at number 4, it says write the number as a product of its prime factors. That just means multiplication, right? The prime factors being multiplied. That's what prime factorization is. It's not listing out the factors. It's showing all the prime factors being multiplied by one another. Okay? All right. Number 3, the correct answer is going to be letter B. So go ahead and do your check or your X. Number 3.
Wait, what learning target is that?
It's learning target number 8. Sorry, I know it got cut off by the hole. Okay. Couple ways you could have done it here. I know a lot of people probably just listed out the multiples of 4. And I don't love that method. But I'm going to accept it this time, even though I shouldn't. The better method would be, remember from your review sheet, you had, remember the first common multiple is always going to be the what?
LCM.
The LCM, right? So that's where I would have liked you have done it like that. And then you would have got 2 times 2 and 2 times 3. They have a CF of 2. And then you'd multiply that by 2 and 3. And that would give you 12. Well, once you know that your least common multiple or your first common multiple is 12, can't you just count by 12s to give you the next common multiples? So that's why it's letter B. Okay? Number 4, same way as number 2. The correct answer is D. But if you did not have a tree breaking down 80, it is wrong. Okay? So I know that 80 is going to break down to 8 and 10, 2 and 4, 2 and 2, 2 and 5. Okay? And then there you go. 2 times 2 times 2 times 2 times 5. There it is. I had some people just simply multiplying these answers out to see which one gives you 80. Not going to work, guys. The work's required. Anytime you're ever asked for prime factorization or product of its prime factors, we're looking for trees. And like I said, guys, write all over this thing. Write all over it and say, write it real big, trees, if you forgot. That way, when you go back to study off this, you can actually say, oh yeah, I missed this only because I didn't have my trees. Because if I'm counting it wrong now, do you think I'm going to count it wrong on the summative? Absolutely. Okay, number 5. The correct answer is D. But just like the rest of them, if you didn't have work, it's going to be wrong. So you may want to hold off on your check or your X. Okay, only because even though you got D, I'm more worried with the process. So what's the first step to finding LCM? What is the first step to finding LCM? Well, yes, but find the GCF, right? Which includes doing your factor trees, absolutely. So again, you must have trees. Now I'm going to start skipping that step just to save a little bit of time, because I think we all know that. So I will tell you that 16 is 2 times 2 times 2, and 28 is 2 times 2 times 7. What do I look for at this step right here? Yes? I look for CFs, common factors. There we go. So what is my GCF here? Abid?
4.
It is 4. So if I know that's my GCF, by the way, do you see how I made 4 an answer? Be careful. Be careful. It's asking for LCM. What do I do with 4 now? Yep.
You multiply 4 times 7 times 2 times 2.
You got it. I multiply it by anything not circled, anything not common. And when you multiply that out, you would get 112. But you must have the trees. You must have, so I'll highlight what you must have. That and that. That's all you need.
Wait.
Okay?
Mr. Garrison.
Okay, let's go up to number 6. Number 6 was probably I think it was at least one of the highest missed questions on the entire thing. Okay, so you might want to circle it, because I can tell you right now, number 6, it will be on the summative. It might not be Xana and Noah, but it's probably going to be 2 people doing something, whether that be doing a puzzle or completing some sort of task, and they're going to complete it at a certain time, and then you're going to have to figure out what time will they both complete it at the same time. So it's going to be the same type of question. So these questions are going to be very, very similar to the summative. So Xana takes 27 minutes to read a chapter of a book. Noah takes 45 minutes to read a chapter. If Xana and Noah start reading at 6:30, when will be the next time they both finish a chapter at the same time? What are some key words here that will help us to identify whether it is a GCF or it is an LCM question? Steve-O?
When?
What?
When?
That isn't one that I identified, but I think when would probably work. I'll put a dotted line underneath it. Yep.
Same time.
Same time, absolutely. What else? Haley? Next time, another one that pretty much is a dead giveaway most of the time. Grace? Huh? Both. It might be, but I don't like to rely on that one. But I like. Remember, there's one word in there that's not actually there, but the meaning of it is there. Yep. Everybody write it for me, please. Future. That's the one I really want you guys to key on, because anytime you're wanting to know when these events are going to happen in the future, we are talking about an LCM question all day long. Right, guys? Oh my gosh. Okay. So this is absolutely an LCM question. Now, what's great about LCM is, don't you have to find the GCF to be able to find the LCM anyway? Yes. So the first step is to do the prime factorization. So you must have that on there. If you don't, it's wrong. Okay? I'll skip it. 3 times 3 times 3 is 27. 3 times 3 times 5 is 45. I see CFs of 3 and 3. So what's my GCF? 9. Now, right away, if you thought the answer was 9, ask yourself for a minute. In 9 minutes, if they started right now, are either of them going to finish a chapter in 9 minutes? No, they're not. So, obviously, that should have been a good catch to know that it's an LCM. Then I'm going to take that, I'm going to multiply by 3 times 5. I'm going to end up getting 135 minutes. But is that an answer choice? No, because it doesn't want to know in how many minutes will they both finish the chapter, which is true. If they start right now, if I set my clock right now, in 135 minutes, would they both finish a chapter? Yes, they would. That's the whole point. But it wants to know what time if they start at 6:30. So you got to take that LCM, because that is definitely the LCM, and you got to apply it, right? So here's my LCM. I need to convert this to hours and minutes. How many full hours are in 135 minutes? Steve-O?
2 hours?
There are 2 full hours. Now, I need to figure out how many minutes I would have left over. How many minutes are in 2 hours? Yep. 120. And then I subtract it from 135, and there's my 15. So I know that 135 minutes is 2 hours and 15 minutes, which if I do 6:30 plus 2 hours and 15 minutes, I'm going to get 8:45. Okay? So hopefully you were writing all that down, or at least correcting your mistakes, whatever mistake you made. Okay? Good?
I do.
All right, number 7. I will tell you that the correct answer is letter B. But you must have work. And what would that work that I would need to see be? What would it be in this case, you think? Yep. Common denominator. What would be a good common denominator to use here? Slammer. 9 would be perfect. Then I only have to change 1. Whatever I do to the bottom, I must do to the top. And there we go. I know that 6/9 of pizza is more than 5/9 of pizza. But you must have that work. Are you guys all hearing me on that?
Yeah.
If you just have an answer, it's wrong. Sorry. Okay, number 8. Okay. Also, is one that, sure, the answer is going to be A, but you must have work. And that work has to start with doing your factor trees. Okay? And then stacking those prime factorizations. Okay, and I see that they have a common 3, and they have another common 3. Therefore, my GCF is going to be 9. Everybody at the bottom, hold on, don't flip yet. I need you to put how many you missed on that page don't put out of anything. If you missed 3, put -3. If you missed 1, put -1. Okay, page 2. I'm going to go start going a little quicker here because now we all should be all good as far as the answers go. Okay, number 9, identify all the common factors of 16 and 36. What is the one factor that all numbers share? 1, right? So can I eliminate letter B and letter D right away? All right, and then, you could just list all the factors of 16. Who's making noises? You could list all the factors of 16 out, or all the factors of 36 and see which ones match. That's the way you probably should have done it. But I'm just going to go ahead and just tell you that the answer is A. I think you guys could have figured that out. You just got to go through and check all the numbers. It's kind of time consuming. Make sure you do your check or your X. Number 10, you're listing out all the factors of 30. So again, A and D should be eliminated right away because 1 isn't even in there. Okay? Then you just see which one's which. And B and C are the same, only C is using multiplication signs. If I just want to know which one shows all the factors, I'm going to show it in a list. So that's letter B. Okay? And number 11, okay, all the common factors between 6 and 12, that is going to be letter C. The only one that has 1 in it, by the way. Okay? Good? Are you guys keeping up with your checks and X's?
Yes.
Okay. All right. Here, number 12, these are learning target 10, both of these. I'll give you the correct answer, then we'll talk about it. This is the answer, 8 parentheses 2 plus 3. Okay? So I'll let you guys do your check or your X there. Okay? What's the first step when you do this? Find the?
GCF.
So again, if you don't have trees, it's wrong. You must show your GCF work. And that's that, and then this would be this. I see CFs of 2, 2, and 2. So what's my greatest common factor? 8. And then you just work backwards now, kind of. You say, 8 times what would get me back to 16? 2. 8 times what would get me back to 24? That's when the distributive property is when you are multiplying the number on the outside by the numbers on the inside of the parentheses. Okay, why is this wrong? Why is that wrong? Because doesn't that equal 16 and 24? Yeah. So why is that wrong? Yes? Exactly. The direction specifically says use the greatest common factor. That is not the GCF, therefore that is wrong. Next one. It's going to be 9 parentheses 1 plus 4. Again, do your GCF, 3 times 3, and 2 times 2 times 3 times 3. I see common 3s. So my GCF is 9. 9 times 1 would get me back to 9. 9 times 4 would get me back to 36. Everybody good with that? Okay. All right, 14, prime composite or neither. What do we ask ourselves right before we do prime composite or neither? Who remembers? Manny? Is it even or is it odd? That's where we start. You may want to write that on your paper if it helps you. Okay? So is 51 even or odd, guys? It is odd. So if it's odd, what does that mean? We have to check. Yep, Steve-O?
By dividing by 3, 5, 7, 9.
You got it. Now, you could go through and actually divide all these. 51 divided by 3, 51 divided by 5, 51 divided by 7, 51 divided by 9. But that's where we have those divisibility rules to save a little bit of time. What is the divisibility rule for 3? Who remembers? Who remembers that rule? Yes, Bridge.
Out of all the digits.
So 5 plus 1 is?
6.
Is 6 divisible by 3?
Yes.
So is 51 divisible by 3?
Yes.
Yes. Do I need to keep going here and figure out any more factors? No, because once I realize that it has at least one more other than 1 and 51, what kind of a number is it? Composite. Composite. Okay? Did you get that? Did you get that one?
No.
Okay, 31. Is it even or is it odd? Everybody? It's odd. So we got to check 3, 5, 7, and 9. 3 plus 1 is? 4. Is 4 divisible by 3?
No.
What's the divisibility rule for 5?
0 or 5.
Does it end in a 0 or 5, guys?
No.
So 5 is not a factor. Is there a rule for 7?
No.
No, you just may have to go in here and do 31 divided by 7. And that would not be. Remember, the rule for 9 is the same as 3, so 3 plus 1 is 4.
No.
Is 4 divisible by 9?
No.
This is a prime number. Okay? The number 1 is neither prime or composite. Neither one. And the reason is why? Yep, Bridge?
Because one only has one factor, one itself.
It only has itself, which is the same number. So the number 1 only has one factor. So that's why it's neither. Real quick, what's the other neither prime or composite that you need to know? Yep. 0. You may want to write this. If I put 1 on the formative, do you think there's a good chance 0 ends up on the summative?
Yeah.
Yeah.
Okay. 15. Is it even or is it odd?
Odd.
It is odd. Get your head up. It's odd. So we got to check 3, 5, 7, 9. Now I could check 3, but what jumps out at you right away that you notice about the number 15? Abid?
1 plus 5.
Well, yes. I mean, you're absolutely right. That's not wrong. But it ends in a 5. That's the first thing I noticed. Can a number that ends in 5 or 0, other than 5 itself, be prime? Hello? No, it can't. So this is a composite number because it has more factors than just 1 in itself. Okay. Next question, number 18 here. First of all, the answer is going to be 36, but you must have work. If you don't have work, it's wrong. Okay? Mr. Garrison changes his wiper blades every 9 weeks, changes his tires, and rotates them every 12 weeks. I did both of these tasks this week. In how many weeks will I have to do both of these tasks again at the same time? What kind of a question is it, guys? Yep. It is an LCM. And how did you know that? At the same time. Slammer? Again is right there. What else? Yep. Future. All those buzzwords. Okay, so the first step to doing LCM is to find the GCF, right? So you do your trees. You must have them. If you don't have them, it's wrong. Did everybody hear me?
Yeah.
So it's going to be 3 times 3 and 2 times 3 times 3. And I see that. Oh, I think I messed up. It's 2 times 2 times 3. See how important it is to do your trees? Because even I mess them up. So I know that the greatest common factor is 3 times 2 times 2 times 3 is going to give me 36 weeks. So that means in 36 weeks I'm going to be doing both. Changing my tires and changing my wiper blades. At the bottom of the page, put how many you missed on that page. Okay, next page.
Wait,
Okay. All right, we're on the next page here. Okay. Okay, I will tell you that the answer for number 19 is 9. So, but you must have work. If you have no work, it's absolutely wrong. And the work you must have the trees. But first, let's go through and read it. Marissa is organizing her DVDs into gift boxes to give to her favorite friends. She wants each box to be identical. What are some key words here? Rich?
Identical.
Absolutely. Whenever you see that word, it usually is a good indication that we're talking about GCF. What other words are there? How about this word right here? Boxes. Remember, whenever we're putting things into groups or sections or containers or packages or boxes, isn't that going to be GCF usually?
Yes.
Yes, it is. Another one is right here in the actual question. Greatest. What is the greatest number? So again, I would need to see the trees for 18, the tree for 45, and then I would want you to stack them up. And I see, what do they have in common? They have a 3 in common, and they have another 3 in common. Right?
Yeah.
What is my GCF then? It is 9. So she can do 9 boxes. So she can give away 9 boxes to friends. Everybody got that?
Yeah.
Okay. Now, for the next question, I'll kind of draw this more visual so you can see it. Okay, those are the boxes. Because didn't we learn that the greatest number of gift boxes she can make is 9? Well, if she has 18 mystery DVDs and she wants every box to have the same amount, how many mysteries are going to be in each one? Yeah.
3.
No. Yes?
2.
2. Because 18 divided by 9, which is the number of groups, is going to be 2. So everybody go ahead and write that for me right here. Even if you don't have it. You didn't have to write it, but it's going to be 18 divided by 9, which would mean 2 mysteries. What?
I got 2 for 20, but I said 3. Does that mean I'm wrong?
It's wrong. If you didn't have 2, it's wrong.
I did have 2.
Okay, that's right. Okay, and then for dramas, you know there are 45 dramas, so that's going to be divided by 9, so that means there's going to be 5 dramas in each. 5 dramas. Okay, everybody see that? Pretty easy. And then number 22, I mean obviously, if you know there are 2 mysteries and 5 dramas in each, then that means there's going to be 7 total. Okay, everybody good there? Okay, number 23. The GCF of 18 and 42 is going to be 6. If you were to do the work, well, you had to do the work. Obviously, you'd need trees on 18 and 42. If you didn't do that, it's wrong. And then you would take it and stack them up, 2 times 3 times 3, and 2 times 3 times 7. You can see that they have a common 2 and a common 3. That's where we get 6 as our GCF. Everybody good with that? I don't think I need to go through every GCF because we've done so many slow. Okay? All right, this one. The answer is going to be 40 on number 24. And again, you got to show your trees. If you didn't show your trees, it is wrong. Okay, that's something that we've done every single time, and there's no reason to not do it. Okay, it would end up being 2 times 2 times 2, and then 2 times 5. You can see that all they have is a common 2, which is why that's the GCF. Then remember, the GCF is then multiplied by everything not used. So times 2 times 2 times 5 would be 40. Okay? Okay. All right. It takes 8 minutes for Marty to finish a crossword puzzle. Anna takes 12 minutes to finish a puzzle. If Marty and Anna start doing crossword puzzles at the same time, how long will they be doing the puzzles before they can complete one at the same time again? Okay, is this an LCM or a GCF question?
LCM.
Absolutely LCM, and the reason we know that is because the word again, the word future, as we've said several times. We want to know when they're going to complete something at the same time in the future. Always going to be an LCM types of questions. So what's step number 1? Find the GCF, so that therefore you got to do trees, look for CFs. Okay, who's doing it? Thank you. So you do your trees, there you go. You're going to get 2 times 2 times 2, and 2 times 2 times 3. I see I have common factors of 2 and 2. So what's my GCF here?
4.
It is 4. And then I got to multiply it by whatever's left over. and that's going to be 24. So that means at 24 minutes, both Marty and Anna are going to finish a puzzle at the same time. Everybody got that? Okay, number 26, if you know that 24 minutes has gone by, and we know that Marty finishes a puzzle every 8 minutes, aren't you going to do the total amount of time divided by how long it takes him or her to finish each one? So that's where you get the number 3. No work really required there. 24 minutes divided by the 3, or divided by 8, because it takes her 8 minutes for each one. Anna, she is going to be 24 and then divided by 12. It takes her longer to do them, so it makes sense she'll get one less done over the time, over the 24-minute time period. Everybody good with that?
Yeah.
All right. Okay, this one, number 28. Mr. Edwards is making cheer bows for Miss Fraser's cheer squad. He has 72 pieces of blue ribbon and 54 pieces of yellow ribbon. Each bow must be identical. What is the maximum amount of cheer bows he can make with no ribbon left over? Obviously, I already got rectangle. The word maximum is definitely a key word there. Everybody agree with that? Absolutely. Also, guys, how about this word again? Groups. Is it making a cheer bow? Isn't it taking the ribbon and putting them into groups, essentially? Okay? If you found the LCM, I think the LCM here, if you actually calculate it out, I believe it's like 216 or something. Would it even make sense for you to, like for Mr. Edwards to be able to make 216 cheer bows if he only has 72 pieces of blue ribbon and 54 pieces of yellow ribbon? Would that make any sense? No. So just think about it. Think about it. He's only going to be able to make 18 cheer bows. Okay, it's GCF. And there, obviously, you would have to have your prime factorization trees, stacking your prime factorizations, and then looking for CFs. At the bottom, put how many you missed on that page, please. Okay, up here, guys, number 29. Okay, this is right here, the number line you're used to seeing right here. What's the interval here on a regular number line? Yes? Who knows what the interval is?
Oh,
Yes?
1.
Would you guys all agree that's 1? Or if I had one that looked like this? 2, 4, 6, 8. What's the interval now? 2. All right? The interval is just how much it goes up by each time on the number line. Okay? So, what's it going up by here? And by the way, when it's fractions, sometimes it's kind of hard to tell. Like, if you just looked and said, well, what's it going up from 1/2 to 3/4? That might be hard. And don't make it harder than it has to be. I always start at 0, and I say if 0's on there, just ask yourself what it's going up by to go. I mean, it's going up by whatever that is, because if you're starting at 0. So what is it going up by? 1/4. 1/4. Okay, number 30. Okay, now, if you don't have exactly that right there, exactly what you see there, it's wrong. Okay, and then I'm going to talk about some of the mistakes that were taking place throughout the week. What?
What if you like
Well, I thought you finished on Friday. I guess count them wrong. Okay, so there's 3 parts to this. Please listen to me real quick. There are 3 parts to this vertical number line that you got to be real careful about. First of all, it has to be vertical. Some people are still struggling with the difference between vertical and horizontal. So vertical is up and down, horizontal is side to side. You must know that. I will count it wrong. Huh? Horizon? Yep, you're right. I agree. Horizon, like when you look at side to side. Okay? The other thing is the word between up there. What does that mean? Alex? Yeah, everything between 5 and 6. So 5 and 6 should not be on there. So that's what I was looking for. What if it would have said to represent fractions from 5 to 6? Yeah? Then you'd put 5 and 6. So you got to start it at 5 and 1/5 because you're going up by intervals of 1/5. Okay? The other thing that people were making mistakes is they were putting 5 and 1/5 at the top. That's why I'd like you to write this now. Bigger numbers go to the top, smaller numbers to the bottom. That's the biggest mistake that students, I just said write something. That's the biggest mistake that students make when they're looking through or doing a vertical number line. They put this, they do something like this. They go and they write it, they go like this, and then they're just not thinking, and then they just start doing this. Because normally when we number stuff, don't we, if we're numbering it down our paper, we start with number 1, number 2, number 3, right? Well, it's just something you can't do. So this right here would be absolutely wrong. Okay, remember, think of a thermometer. Okay, and then number 31, since it says between, odd numbers between 11 and 21, we would not include 21 and 11 on there. And the first odd number after 11 is 13. And the last one before 21 would be 19. At the bottom, put how many you missed. Okay?